Hi everyone! I would like to finish this course by working on a small project. This way we can review the most important points of this chapter, such as working with either, as well as designing an error enumeration. It will also give us the opportunity to discuss new subjects, such as functional data modeling. Okay, so let's open the file order.scala, located in the package exercises.errorhandling.project. During this course, I often use the example of an order management system, such as Amazon, where we start an order with an empty basket, then we select a few items we want to buy, and finally we go through the checkout where we enter various details, such as the delivery address and the payment method. The goal for today's project is to implement part of the state machine for this order management system. Let's start by reviewing the order class. Order is a case class with several fields: a unique ID, a status which can either be draft, checkout, submitted, or delivered, a basket which is a list of items where an item consists of an ID, a quantity, and a price, an optional delivery address. It's optional because it's only set during the checkout process. And finally, a few timestamps that collect the time at which some actions were performed, such as when the order was created, submitted, and delivered. Now, you might have modeled this class differently. However, let's assume that, for the moment, this data model cannot be changed. For instance, we already have lots of data in our database that use this representation, and it would be very painful to migrate. So for the first exercise, we are going to implement the method checkout, which is called when a user has selected a few items and wants to finalize the order. So checkout can only be called if the order is in draft status and the basket contains at least one item. If both conditions are met, the order moves to checkout status. Otherwise, the function returns an order error. The specific errors depend on the cause of the failure. If the order is in another status than draft, then we expect to get an invalid status error. And if the basket is empty, we expect to get an empty basket error. Cool, so I'll let you pause the video and try to implement and test checkout. Okay, so I suggest that we start by pattern matching on the status field. So we can say something like, if the status is in draft, then we need to verify that the order has at least one item. And if it is not in draft, so let's say if we get an other status, then we want to return a failure. So this means that if it's not in draft, we said we want to return an invalid status error, and we'll supply the status that we are currently in, so that we can provide a decent error message. Okay. So now we need to implement this branch of the pattern match when we say, okay, we are in draft, so that's good, we satisfy the first conditions. Now we need to verify if the basket is empty or not. So now we can say if basket is empty, so if the basket is empty, we want to return an error that is an basket, what was it? It's an empty basket error. So we'll say empty basket error. Otherwise, this is a branch where we want to, actually we succeed, like all the conditions are met. So we want to move the order to checkout, which means that we are going to return a write because it's a success. And within this write, we need to return a new order with the status updated. So how do we do this? We can call the method copy because order is a case class. So copy allows us to create a new immutable object that copy all the fields from the existing one. But we can specify what we want to change. So we only want to change the status, and we want to move the status to checkout. Yeah? Okay. We can even put this in same line, whatever you prefer. Okay, so let's run the test. So I think there is a few tests for this. So I wrote a few examples. So here it's a case where it should actually work when it's successful. This is a case where the basket is empty. And this is a case where the status is invalid. Like this is where we try to call checkout when the status is in delivered. Okay, so let's give it a try to see if we have implemented it correctly. Yeah, it all works. Now, before we move on, I would like to refactor quickly checkout. I don't really like that at the moment we pattern match on a string and we use a string in the status. Now, we can't yet change the case class. We said that so far we are not going to touch the modelization of the order class. But pattern matching on strings everywhere is very brittle because it's very easy to make a typo, like using draft in lowercase, in uppercase, and so on. So one way to improve slightly, we'll still maintain the string encoding, but to have a slightly better representation is to create an object. So we can call it like order statuses. And within this object, we are going to define all the strings that are valid for application. So we can say draft is a string that is currently equal to draft. And then we'll basically create one variable for each valid status. So we'll have checkout, we have submitted, and we have delivered. Once we have defined these 4 variables, we can use them in our code. So obviously we can use it here. So let's import all of them in scope. So we can say order statuses. Now we can use draft here, right? It's just a variable. We say that we want to set the status to draft. But we can also use this variable in the pattern match. So we can say if the status is a draft or checkout. So this will be equivalent to say that status equal draft. Now one thing to bear in mind is that if this variable was using a lowercase d, so if the first letter wasn't if the variable wasn't capitalized, we need to use backticks in order to use it within a pattern match. So this is called a stable identifier. I'll add a link below this video to describe this feature. But just for you to know, it's better in this case to define this variable using to capitalize it. This way we can use it without backticks in the pattern match. Okay, so now that we have done this, we can replace every single instance of the status in our code. So we can say draft, checkout, and so on. Okay, so let's check we haven't broken anything. Yeah, it still works. Okay, so next we're going to implement the method submit, which is called once we have all the necessary details to send the order and schedule the delivery. So submit requires the order to be in checkout status and to have a delivery address. If both conditions are met, the order moves to submitted status and we store the timestamp at which the method was called in the submitted at field. Otherwise, the function returns an order error. You may need to extend the order error enumeration to cater for all error scenarios. I'll let you pause the video and give it a try. Okay, so let's start by pattern matching on the status, as we have done before. So we can say if the status is in checkout, and we can use the variable we just created, then this is potentially good. So this is one of the requirements. And if the status is not in checkout, then we know that the status is invalid, so we can return an invalid status error. Okay, so what do we do if the status is in checkout? We need to verify that there is a delivery address. So we need to verify that at some point the user called the update delivery address during the checkout process. So we'll say delivery address is an option of an address, which means that we can pattern match exhaustively on it. We can say if there is no address or if there is one, like that. Okay, so if there is no address, then it's an error. I don't know yet what we're going to return. And if there is an address, then we can move on and duplicate the order, move it to the next phase. Actually, we don't really care about the content of the address. We just want to check that there is one. So we can use an underscore here. Now the question is, what should we return if there is no delivery address? So let's have a look at the order error. This is an enumeration with only 2 cases at the moment. We have an empty basket error and an invalid status error. None of them really fits for this situation where the delivery address is missing. So we could very well add a new case to this enumeration to say, for example, missing delivery address. Yeah, it perfectly describes what happens. Then here we say, okay, if the address is none, we return a left of missing delivery address. Now, if the address is here, we can move forward. So we're going to create a new order using the copy method. And what do we want to change? We want to change the status. So the status is now going to be submitted. And we also want to store the timestamp at which this method was called. For example, we'll say submitted at sum of now. Cool. Okay, so let's run the test to see if it works. So we do have, again, a few example-based tests for submit. So let's enable them all. And let's run the test suite. No, there are a few failures. So here, what does it say? Oh yeah, so this test checked that the address, what happened when we call submit, and there is no address, so the delivery address is none. But the test failed because there is a triple question mark for the error that we expect. So this is because it wasn't defined yet. So this is missing delivery address. So let's rerun the test. Now this one passed, but we have another one which fails here. So this one, what does it do? So it's actually checked that if we call submit, but there is no item, the basket is empty, we do expect to get an empty basket error, while at the moment we get a success. So this is actually a weird test and in fact a weird situation, because that's true that potentially here we could call submit on an order that is in checkout status where the basket is empty, but it doesn't really make sense because normally the only way to arrive to this state, so the only way to arrive to checkout status is when you call the checkout method, which does check that the basket is not empty. But at the moment here, there is no way to prove that we have already checked this. So if you want, this knowledge is known by the developers who implemented these functions. But here, there is nothing that proves us that we did this check before. So here, there are already two cases. Either we say, okay, we do know that we have made this check before, so we're not going to double check. Or we can say, okay, let's verify again. It doesn't make much sense, but just to be safe, kind of. So let's do that for now, and we'll look at it in the next video. We'll look at other options to actually make it safer. Okay, so what we could do here is basically duplicate this code. So, okay, if the basket is empty, we return a left of empty basket error. And then we can say else. Or actually, we could kind of let's make it a bit nicer, the code. We could say if the delivery address is empty, then we return a left of missing delivery address. Else, this is a third case, we return a right. So I refactor it using an if then else just to make it a bit more standard. Okay, so now we have three cases. We check that the basket is not empty. We check that the delivery address is not empty. And if both these conditions are met, we do move to submit it. Let's run the test. Yeah, now they pass. So finally, let's implement the method deliver, which is called when the user receives the package. So deliver can only be called if the order is in submitted status. If this is the case, the order moves to delivered status. This is the last status in the workflow. And we store the timestamp at which the method was called in the delivered at field. Additionally, if the method is successful, we also return the time it took to deliver the order, which is the difference between the submitted at and delivered at timestamp. And we'll return this time as the Java time duration. Okay, so great. I'll let you pause the video and try it out. Okay, so let's implement deliver. So we'll start in the same way. We'll pattern match on the status. We say that if the status is in submitted, then that's good, that's what we want. If it is not the case, we return a left of invalid status, exactly like that. Now, if it is in submitted status, then what do we need to check? Actually, we don't need to check anything. If it isn't submitted, then that's good. We can, just mark the order as delivered. So we could say like, we could return a write, but since we're going to return a tuple, maybe it makes sense to create variables to make it a bit more readable. So this will be like the new order, or the updated order. Let's call it updated order. So the updated order is going to be the current order with a status equal to delivered, and the delivered at timestamp needs to be set. So we'll take it like this. So this will be the new order that we're going to return here. And now we need to calculate the duration, the time it took to deliver the package. So this is the difference between the submitted at and the delivered at timestamp. Now, there is, if you look at the Java time duration, there is a method called between, where you need to specify the two timestamps, and it will calculate the difference. So this is a start. So the start is going to be the submitted at, and the end is basically now. It's the delivered at. Now there is a problem here because the submitted at is an option. And yes, it is like it is set. We set it at the moment of submitted, at the moment we call the method submit. And this is, in fact, it's a very similar situation with the basket is empty. Here, if you want, the only way to call the method delivered is that the order must have been submitted before. There is no way to receive an order if it wasn't submitted. Yet, when we call deliver on this object in the submitted status, we don't have the guarantees that submitted at is a sum. The data model doesn't guarantee us this. We know it, as a user, we know that it must be defined, but the data model doesn't show this knowledge. So again, like if we want to repeat the same process, so if we want to be safe, we'll have to pattern match on submitted at to verify that it is defined or not, which is annoying because we know that it must be defined. So, this will be the timestamp. So in this branch of the enumeration, or on this branch of the pattern match, we can calculate the duration. This will be like that. In fact, let's move everything like this. And now, so if we do have a timestamp, we can return a success. So this success will be the updated order and the duration. So this is a branch where it's successful. Now this is a case where submitted at is not defined. So this is annoying because we must return a left. It's an invalid scenario. But first we know that it's impossible. It should never happen. And also we don't have a case yet to cover this situation. So if we want to be safe, we could define a new object that says, for example, missing a submitted at timestamp, if we really want to be verbose, and then go back to the order, and in this case, return it. Okay, so this is not an amazing situation, but let's run the test for now, and we'll discuss a bit later how to improve this. So let's have a look at the test for this function. So what I've done in this case is that instead of writing just one example best test for deliver, I wrote an entire workflow test. So something that checked the entire life cycle kind of an order. When we start with an order that is empty, so just a draft order that we just create, and then we have a for comprehension where within this for comprehension we do all the actions that a normal user would do in the platform. So we'll say, okay, let's add one item, let's add another item, then let's do the checkout, update the delivery address, submit, and then deliver. And then at the end, what we verify is that the order is in delivered status, all the items are there, all the timestamps have been correctly set, and the duration have been calculated correctly. So I use the for comprehension here because every single method returns an either. So if you want, every single method here can fail, but the nice thing about the for comprehension is that they let us focus on the happy path. If any of these functions fail, it will just return a failure, it will stop automatically, it will return a left. Now, I use a technique in this test that I'm not especially proud of, but it is a bit convenient. It's the fact that I'm shadowing the variable order. So it looks a bit weird. You see, like we call order.addItem, and this returns order. So what it actually does is that addItem returns, in case it's successful, it returns a new order. So I could have given it a different name, order2, and then call order2 here. But then it would not have been extremely convenient for refactoring. You could imagine later maybe our team decides to add an extra step in the workflow, and in the middle, we wouldn't want to rename all of the variables just for this. So this way, I'm kind of like shadowing the variable order. I erase it, I replace it every time. So it's a trick, you decide which one, if you want to use it or not, but I find it quite convenient for using within a for comprehension, and when we have something that we kind of always want to replace. Okay, so now let's run the test to see if it works. Yeah, it works, nice. Now let's talk about property-based testing. What sort of properties would you write for these functions? I'll let you pause the video and give it a try. You can find a few generators for this data model in the file order generator. So for example, here there is a generator for instant, duration, item, and so on. So I'll let you pause the video and try to write a property-based test for these functions. Okay, so if I had to write a property-based test for this code, the first thing I'll start with is to try to generalize the input. Because if you want this test is very generic, we just want to check a traditional, like a standard workflow for a user, a standard happy path workflow. But we don't really care if they add like 2 items or 1 item or 10 items. We would like to generalize it. Same, we don't really care what is the address, how long does it take to deliver, and so on. We could randomize this input. So we can start like this. So let's try to generalize one input after another. So how do we do this? We first try to generalize the order ID. So let's see, do we have an order ID gen somewhere? So let's look at the generator. What do we have? Yeah, we do have order ID gen. So we can call it here. Actually, we need to import it. Okay, so this will be the order ID. And now, if you want, we can already copy-paste this entire code and move it inside of the for all properties. So now, really, the only thing I've done is that I've randomized the order ID, and that's it. The entire test is the same. We can rerun it to see that it already passes. And now we can keep iterating like that. So we can say, okay, let's randomize the next variable. So we should have an instant generator. And this will be called created@. Yeah? Let's run the test. Same thing. It works. Okay, so now, if you look at this, submitted@, and delivered@, there are duration that are from created. So here we say created plus seconds plus 5 seconds. So actually we could generate a duration, so something like an amount of time, and then add it to created. So we could say something like duration gen. So this will be called like delay, maybe submitted delay. And what we'll do is that we'll just say, instead of plus seconds, we can say just plus, and I think it will work. So here what we say is that we generate a random duration, and we say that submitted@ is created@ plus submitted delay. Same for the next, for the delivered@ delay. So we say delivered delay, and we'll say this is this. Yeah. Let's run the test. Now it doesn't work. Why it doesn't work? So let's check what line. Oh, I think I know what it is. So here, if you look at this, at the moment when we verify the result, we verify that the first part of the tuple is the order, And we also verify that the second part of the tuple is the duration it took to deliver. Now, the duration it took to deliver is not 30 hours. No, it's randomized. So actually, this should be the delivered delay. We call it like this, delivered delay. Let's try it out. Yeah, now it passes. Nice. Next step. So what do we want to do? So now the interesting bit is that we want to generalize the number of items. So we can generate, so we do have an item generator. So in fact, we could say here item 1, so item, so this will be the random item that we generate. So let's give it a try. So the second item is still hard-coded, but yeah, it works. Now we could repeat this process for item 2, generate a new item, but instead what we could do is generate straight away a list of items. So we could say item gen.list of, and this way this is going to generate a list of items. But actually, we don't want just a list of items, because if we generate a list of items, it might be empty. And in the happy path, we need to verify that there is at least one item that we generate. So there is actually a generator. What we would like to do is generate a non-empty list. So I created one here. You can say nil of items. So the no items is a non-empty list. So this means that if we wanted, we could say items.head, and it should still work. Let's double check. Yeah, cool. So potentially now we can remove this. So we can say, let's just use straight away the list of items. And at the end, we'll verify that the basket is equal to, we need to convert this non-empty list into a list, because the model only uses a list. Now this means that here, within the for comprehension, we need to submit, we need to add item for every single item inside of this non-empty list. So what we could do in this case, and it might actually make sense, is to update, to create a new function, add items, that will allow us to submit several items at the same time. It actually might be very useful, like why do it only one by one? We may want to be able to do it several by several. So we'll do a non-empty list because it doesn't make sense to add a list of items. And here the implementation will be items.toList, and we can just say ++. So if you want, the implementation is very straightforward. We just, instead of adding one item at the end, we add a list of items. And in fact, we could even also refactor add item to be, in fact, a special case of add items where we put a non-empty list with only one value. So again, this is not necessary, but these methods are most likely going to be useful, and they don't really cost much to define. Okay, so now this means that we could say add items, items, like this, and I believe it should work. Let's give it a try. Yeah, nice. And I think we are almost done. We only have one thing hard-coded yet, is the address. So we can also generate a new address, address gen, like this. So in fact, let's call it delivery address. And I believe that's it. So it works. And also, let's change the string here to replace it by the status that we created, I mean the variable we created. Let's rerun it, just to double check. Yeah, all good. Nice. So as you can see, it's not that difficult to generalize an example-based test. We can just pick up every single hard-coded variable and generalize it using a generator. So the thing that takes the most amount of time is to define these generators. But if it's your data model for your application, it kind of makes sense to define these generators, because you can reuse them to write many tests like this. Now, another property-based test we could have wrote is to verify that each action is only allowed in some state, in some statuses. So what we could have said is something like, we can verify that checkout is not allowed if order is in checkout submitted or delivered status. So we know that one of the requirements for checkout is the order to be in draft. It needs to be in draft and have at least one item. But at least we can verify that if the order is incorrect, is in incorrect status, then it should fail. Now, which means that here what we could do is to try to generate an order that is either in checkout, submitted, or delivered status. Now, if you check the generators, what I've done is that I created a generator of order for draft orders, a generator for orders which are in checkout, one for submitted, and so on. And then we can combine all these generators using the method one-off. So one-off, what it does is that every time it generates a random value, it picks up one of these generators. Now we can do something similar in our test. Now we can say here, let's generate an order that is, okay, so let me import them. Maybe I need to import everything within the generator to make it simpler. So let's generate an order that is in one of these states. So we want to be in checkout, submitted, or delivered. We don't want to generate an order in draft because it might be valid if it is in draft. So this will generate an order. And now we want to verify that if you call checkout on this order, we do expect it to fail. And we do expect it to fail with invalid status order.status. Yep. So if you want this test, what it does is that it verifies that if the order is in one of these statuses, then it should be impossible to call checkout. It's invalid. Let's run the test. Yeah, it works. So this is one example. You can repeat the same process for any other actions. Great. So today we have seen that it's quite straightforward to handle errors using either. The main idea is to define an enumeration that describes all the possible reasons why the workflow can fail. We also notice that a few of these cases should never occur in practice. For example, if the order has a submitted status, then it must have a submitted at timestamp defined. However, there is nothing in the order class that enforces this constraint. It's only a comment in the code base or maybe a note in a wiki page. This is quite annoying because we need to define an error class for a situation that is theoretically impossible. So in the next video, we look at redesigning the order class in order to minimize these impossible scenarios. See you soon.